Okay, here I go. I've got all my pieces. I've got 7 of these wires, male end on both sides. I've got the Uno Arduino. I've got my little connector. I've got my, unfortunately, very hard to see mini breadboard. I've got 3 LEDs and 3 resistors. These are 330s. Anywhere that's like 200 to 330 is probably good enough. Anything too big and it's going to resist past the point of your ability to see the LED, and anything too small, it'll fry your LED. You might have a different kind of breadboard that has like a whole line that's just for ground. This is a mini breadboard, so I have to make up my own ground. So as a reminder, when you have a breadboard like this, generally the idea is every one of these rows here is like a glob of solder. So glob of solder, glob of solder, glob of solder. These are not connected. These are all individual globs of solder, but these are all the same glob of solder. So if I stick something in here, 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 and here, it's like I've stuck them all in one giant glob of solder. So since I don't have ground here, what I'm basically going to do is just pretend all of this is ground. So I'm just going to identify for myself that this is ground. And I'm going to connect all of these to ground, which is going to be over here. Okay, so now you'll notice when you have your LEDs that there is a side that is short and there is a side that is long. This is really important because if you put it in backwards, it's not going to work. And in no way did I rediscover this because I totally did this video backwards and had to re-record it. Okay, so what we're going to do is, you see, in other videos that we may have done before, you may have seen, we'd use these analog pins, and the analog means it can go anywhere between like equivalently 0 and 1, so you can have it 50% on or whatever. These are digital pins, which means they're either 100% on or 100% off. So what I'm going to do is I'm going to connect the first one, 8, digital 8, and I'm going to connect it to here. Okay, so remember that this means that I'm now connected to anybody else in this first row. Okay, now it doesn't matter what color wire, and you're like, why would it matter? Well, you know what? The first time I remember doing these, I thought, well, there's different colored wires on purpose. There must be a reason. They must do different things, but they don't. They're just for funsies. Okay, so basically, if you just plug this in, this is going to fry. So you have to put it on a resistor so it reduces the amount of current that goes through it. But if you put it in the wrong way, it doesn't work. So the way you kind of remember it is you remember that... This is really stupid, but the short side goes with the resistor on the resistor side, and this goes directly into the wire. I mean, it doesn't, just, okay. I'm putting it in this way, and the way that I just always do it this way, and I just always remember that it works, except for the time that I just completely flipped it in my head, is this is the nice side that has never been resisted, and this side has been resisted so much it's shorter. It's stupid. Oh well, this is what you get for free videos on the internet. And then I'm going to just stick this in here. And honestly, wherever it goes in, that's where I meant to put it. Okay, that's where I meant to put it. The only important thing is that these two guys aren't in the same column or whatever you want to call this. They're just on different soldering globs. Okay, so whatever this guy, long guy, is attached to this guy, short guy is going to be soldering globbed to resistor. All right, and then resistor I'm just going to throw over here, and it doesn't really matter where. So I said I was going to make this over here ground. So really the only thing that matters is that the resistor goes to ground. So in theory, I could make my resistor go all the way over there, but that's kind of sloppy. So what I'm going to do is I'm going to have my resistor go over here, and it doesn't have to be in the same column as the one I'm in now. I'm just kind of doing it for prettiness sake. And then I'm going to connect that solder glob. I didn't even make it. I put it in the first one. I'm going to connect that solder glob to ground. Okay, then I'm just going to do that 2 more times. So I've got number 9. That's not number 9, that's number 10. Number 9, I recommend reading glasses if you need them. Reading, and over here. All right, so this guy has been resisted, and so he's shorter. And so I'm just going to throw this in here, and wherever it goes is where I meant to put it. Ah, these guys are such a mess. And this is why growing up I always thought I was never meant to be an engineer, because I'd see other people do this and they were just so good at it and I was so bad at it. You know, like those things whenever you're supposed to make like egg catapults in physics class, my eggs always died, and therefore I must not be an engineer, because clearly most engineers all day make egg catapults. And that's a big part of engineering. Therefore, I must not be destined to be an engineer. Okay, so now short side, because it's been resisted so much it burned away. And that's true, it's just how I remember it. Goes over here, shove it in there. Yay. Oops, please don't drop resistors into the carpet. All right, and then this guy just goes on to glob, over to ground glob. Okay, and then D10 goes, well, let me just throw this in where it happens to go. Wow, that's where I meant it to be, totally. Okay, and then line goes into long side, and then short resisted side goes here, and then I throw it over here somewhere, and then I connect that glob with ground glob. And now I finally actually have to attach ground glob to ground on my Arduino, which is labeled. There's two of them, but I always use this one because it's pretty. And look at this beautiful circuit I have that everybody would be soups gel from Miss What's-Her-Name's physics class if they could see me now. And there we go. Okay, let's see if this actually works. We're going to plug this in. Meow. And I'm going to plug it in over here to my computer. It's ready to go. So if this is the first time you've put this Arduino plugged into a computer, it might take a little bit longer to get started. I'm going to just come over here into the sandbox and just see if I can get my code to work before I try to actually integrate it into my Simon code. So just to see if I can get MATLAB to talk to it, Arduino, proop, bump, run. And again, if this is the first time that I've run this, it could take up to a couple of minutes. But the good news is that once it gets set up, good, mine is already done, then over here. Now, if I try to run it again, it's going to say it's already been established. So I guess you could CLC clear and it'll rerun it every time. But it will take a little bit of a while. So if you don't want to have to mess with that, you could just comment it out for a while, and then whenever you're done, CLC clear and move on. Okay, so the pin that I want to start with is, I'm going to call it DA, so that stands for digital pin in number 8. I'm going to configure the pin. So the first thing we need to do is configure that pin on the Arduino. The pin itself, and we need to configure it for digital output. Okay, so we need to specifically say we're using this as an output pin. And now specifically we want to write, whoa, none of that was what I wanted. Now we specifically want to write to our digital pin on the Arduino to the specific pin number pin. We want to set it to 0. Okay, so nothing should happen because it's clearly already off. So we're going to pause for just a minute, and then I'm going to turn it on and see what happens. Hot damn, my light turned on. I'm so excited. Okay, let's see if number 9 turns on. Now, if it didn't turn on, okay, so if it didn't turn on, first of all, make sure you have shorty end attached to, what do you call it? Attached to resistor side. Because if I flip that, it will not work. Make sure your grounds are connected. See if the ground isn't working, if anything isn't working. Now that said, if you have everything wrong, none of them will work. So before you get too freaked out, just try doing number 9 and then try doing number 10. So if 8, 9, and 10, none of them work, then you've done something consistently wrong, which is great, because once you figure it out, you'll fix them for all of them. If you've got 2 out of the 3 working, it probably just means you didn't push the pins in far enough. There's a sufficient number of times that it has just been easier to take the whole thing apart and then rewire it. It doesn't take that long compared to actually getting mad at it and yelling at it. So there you go. Just for funsies, let's go ahead and I'm going to adjust this now just to kind of practice what we're going to use. Let's call this pins D8, D9, and D10. Okay? So now what I think I want to do is for K goes from 1 to 3, just to kind of show you what we're going to do here in a minute. We're going to turn them on, and then we're going to turn them off, just to make sure that this is something we can do. Okay? And if we get this working, then we know that we're ready to integrate this into our Simon game. Okay, so blomp, bop, bop. Uh-oh. Must not exceed 1. Oh, pins. Okay. Shaplomp. Oh, I turned them all on. Let's turn them all off. Okay, you know what I should probably do first is turn everything off. And then I should turn everything on and then turn it off again. Okay, I think that's what happened. Okay, I could do that. And I could even do that, 5 times. 2, 3, 2, 2, 3, 3, 2, 3, 4, 2, 3, 5, 2, 3. Awesome. Okay, so I can definitely flash pins. That means I have hardware that's working. In theory, I have some version of software that's working. So the hardware works. I can talk to the hardware. Now the next step is to actually get code to do what I want it to do to make my game the super awesomest Simon game that has basically ever existed. Okay, let's do it.